All right, guys, so I think that we got into linear functions, equations of lines and such. Can somebody tell me one of the two equations of a line?
Y equals mx plus b.
Kick ass. All right, she's like, let me grab that one. Can somebody else tell me the other one? Oh, okay. So there's something called standard form. This guy here, this guy's shit. He's complete shit. Doesn't tell me damn thing. So one is y equals mx plus b. Let me be a little careful. That's not complete shit. But for the moment, it's complete shit. What does this one tell me? If I have an equation in this form, what does it tell me? Slope.
Slope-intercept form.
The slope-intercept, so it tells me the slope and the
Y-intercept.
Y-intercept. Kickings. I love it. I did not get it at all. So real quick, if I have this equation, what's the slope? See it? -2/5. What's the Y-intercept? Almost?
1.
No? Okay, I'll tell you this much. -1 is part of the answer.
0, -1.
Yeah. Whatever, math boy. Picky boy. Alright. Y-intercept's a point. That's the correct reaction, but understand you gotta be picky for a reason. Y-intercept's a point. Point's got two parts, right? At least for us right now, because we're living in 2D mathematically. It's got two parts. Alright, so that's basically a lot of what we went over yesterday. The really last thing we did was we figured out how to create the equation of a line if they give me some information. So everybody with me? Okay. One thing I want to remind you about, what's true about two, you made it. What's true about two lines that are parallel? What must be true about their slopes? Yeah, if they had different slopes at all, they would eventually run into each other, correct? So to stay parallel, they have to have perfectly the same slope. You with me?
Yeah.
So parallel line, same slope. And I'll say it really specifically, exactly the same slope. So what do you think about perpendicular lines? What's perpendicular meaning again?
90 degrees.
Yeah, they meet at 90-degree angles. It's like that. So one line could be like this, and the other line would have to be like that. So they meet at a 90-degree angle. Does that make sense? So obviously the slope is at least not equal. Does anyone have a guess how the slopes would have to relate?
Say what?
Does anyone have a guess? Like if this line here, let's call this line 1, and we'll call this line 2. Say line 1 has a slope of 2. Does anyone have a guess as to what line 2 slope is going to be? Negative is good. And also...
Well, it's going to have to include a 90 degree somewhere.
No.
No?
The slope doesn't have that information. That's just a fact of how the lines meet. The slope doesn't have to know that shit.
No?
Nope. If the slope is a certain number, they will meet at a 90-degree angle. It's not the 90-degree angle causing the slope to be something. Does that make sense? So 90 is not going to show up. So you know it's going to be negative. It's 70 degree. That's obvious, right? In order to be perpendicular, if one's going up, the other one's got to be going down.
Yeah.
The one that's not as obvious is it's actually the reciprocal also. And very quickly, if I had a slope of, can anyone tell me the slope of this line here?
Y equals x.
No.
Oh, I'm ready.
What's the slope? It goes up.
Y equals 3x.
Yeah, over, so I did 3. 3 is the slope.
Oh.
And you're right, y equals 3x is the equation. I didn't need that much. You guys all with me?
Yes. Rise over run.
Could you all graph that for yourselves in your notes? I'm going to ask you to do something. Make sure your scale is decent, right? What I'm about to ask you is a little unfair, and I don't care because I'm not going to look at it. It doesn't have to be perfect. Can you try to make a perpendicular line through the origin? So obviously it wouldn't be this. You guys agree? That would be silly. It's got to be perpendicular, and that's got way too small of an angle. So it's going to be somewhere over there. Are you with me? So try to draw that. Try to draw the line that goes through the origin at a 90-degree angle to that line. This is nothing you're going to have to do for homework, right? It doesn't mean it's not valuable. Okay. So let me try it myself and see. Maybe something like that. Yeah? Do you guys, this is a bad example, but I need you to notice this slope is not as big as that slope. This slope is smaller. So that's why it's not just the negative. It's actually the negative reciprocal because it's smaller by exactly the amount that this is. It's smaller by 1 over that. So if I make a little more extreme example, if I had a slope of like 7, the perpendicular would come in like this, it would have a slope of 1/7, negative. So this is why I like to say parallel lines, exactly the same, perpendicular, totally opposite. Right? So when I say opposite, what do you think of mathematically?
Reciprocal.
Reciprocal. You can also think what's the opposite of something could be the negative. So do both. Exactly the same parallel, totally opposite perpendicular. Negative, reciprocal. You guys with me? Okay, good. I don't know, does this sound familiar to anybody? A little bit? Okay. So for example, if I had, parallel is easy as shit, yes? So if I had a line, y equals 3 halves x minus 7, and I have 3y, you can do it, Jeff, plus 2x equals 11. So this is line 1, this is line 2. If I ask you, are those parallel or perpendicular or neither, because obviously they could be not parallel but not perpendicular, right? What the hell would you do? Can you tell the slope of one of those lines just by looking at it? Yeah, which line do you know the slope of? First one, what's the slope of the first dude? So the slope of the first dude, 3 over 2. What do you do to figure out the slope of the second dude? Solve for y. Right, so just to cut to the chase, subtract 2x, divide by 3. That's gross, I don't care. Can you tell if they are perpendicular or parallel? What are they? Now, one slope is 3 halves. Is that the negative reciprocal of that? There you go. They're perpendicular. Big axe. I know. Okay. So that might pop up in some of the homework. Hold up. So what we're going to do today, if I say it a certain way, it'll freak you guys out. The official name of what we're doing is modeling situations with linear functions. Well, that's freaky. But if I called it word problems, that would really freak you out. But yeah, let's see. Let's do a problem like, okay, we'll do that. So any function that we learn about in math could possibly model a real life situation. We already talked about the fact that if I throw something and there's no wind and all this other stuff, if I throw something to somebody else, it's going to follow a parabolic path. Is that cool? You guys with me? There are comets that follow parabolic paths. There are comets that follow elliptical paths, right? You guys know a comet that comes back every now and again? Halley's Comet. Mark Twain was born when it came and he died when it came again. So that comet is like, live, and then it said, okay, that's enough. You guys kind of with me? Okay, all right. There's other comets that come by. There's one a while back, I remember my friends and I went out and saw it. It was called Comet Hyakutake, but it looked like Hayakute. So we always call it Hayakute, but it's Hyakutake. Comet, hail bot. Anyway, that's enough.
Hail bot.
Hail bot. Okay. So what the hell is this gonna look like? Well, let me give you a situation in the real world, which is always nice. Let's say you call a plumber, and they charge $45 just to come to the house. And on top of that, they charge, I'm going to show off that I've never had a plumber come around, $30 an hour. You guys with me? So let's just feel this out. What if the plumber came out and stayed 3 hours? Right, how much money would I have to pay them? Second? How'd you figure it out? Yeah. So it's 45 to come out, plus 30 per hour kick ass. Is that cool? Love you guys so much. So that would be 135, yeah, 90. If we stayed 6 hours, of course you would do the same damn thing, correct? So one thing that algebra does for us is, instead of just coming up with possibilities, we just put every number in at once. So instead of 6, I'll say, what if you stayed X hours? So then what would that be?
30x.
Yeah, 30x
Plus 45.
plus 45, I love it. So there's a lot of situations where there's a price per something. Like if you call the psychic hotline, is another one I like to do. And it costs so much money just to call, and then it costs some money per minute. You with me? Okay. Somebody else could charge per, I don't know. I'm thinking about like picking stuff per strawberry that's picked or something. Right? So you get more money if you pick more strawberries. Are you guys with me? So you get like a base amount plus some weird strawberry commission. Okay. Are you guys semi with me? Are you guys all right?
Yeah.
There's a lot of problems where there's a base amount and then there's a per something charge. Hey, you made it. The other kind of problem you're going to see in here. This is section 4.2, by the way. Let me see if I can find a decent example. I can make one up and I won't see. So what if in 1990, the population of some town, we'll call it Townsville. Population of Townsville was 500 people. In 2008, the population was, what do you got, Jeff? Let's see. Doesn't really matter that much. Let's go 2,300. Yeah. So this little town is just exploding. Okay. And I want a linear function that models the population. Now, I need you to understand, we did a problem just like this last time. I just didn't put it in word problem kind of like form, right? Did you guys see that I gave you 2 points?
Yeah.
All right, I'm going to ask you what the points are, and then I'm going to show you how to improve them, because at the moment, the points suck. Does anyone not, well, let's see. Does everybody see that there are 2 points? Does everybody agree I gave you 2 pieces of information?
Yeah.
Good. How can I summarize this piece of information as a point? 1990. 500. All right, so somebody else tell me this information.
2008,
2008, 2300. You guys all agree that those points are a little bit gross? I mean, look at the freaking X values, right?
Yeah.
So let's improve that a little bit. I need you, this is what students don't get. And of course, it's not your fault because you didn't get enough time to play with this shit. We set up the variables. We are the humans. We created math. So I can set up the variable to mean something. So that when somebody uses my equation, I have to tell them, oh yeah, X means this. So they put the right stuff in. Are you guys kind of with me? So I can define, instead of using the full year, I can define my X to be years since 1990.
Yeah.
Do you guys understand? Because all that really matters for this is how much time has gone by, correct? The whole idea here is time goes by, more people. Maybe people making people, or people moving in, or whatever. You guys kind of with me? Yes? Okay. So then what would this point look like?
0, 500.
Why does that point kick so much ass? What's
It's a baseline.
it's the y-intercept. Do we already know what b is? Yeah, b is freaking 500. Kick ass. And this point would become
18,
yeah 18.
2300.
2300. So we already know the b is 500. What's the only other thing we need to figure out the equation? All right, so take a minute, figure out the slope. I made it kind of nice. You found us! Was it confusing? I'm sorry.
100 over 18, so 100 over 1.
Yeah, so if you do the slope, y2 minus y1 over x2 minus x1, you'll get 2300 minus 500 over 18 minus 0. So those will be 1800 divided by 18, you get 100. Is that all right? Now the mistake people make is they'll do a problem like this and they'll circle that. No, what's the answer?
Why?
Oh, I'm sorry, you guys just came in, so go for it, Jeff. I don't know. Yeah, what's the answer? What was the question? Find a linear function that models the population, right? So it would be y equals 100x plus 500. Yes. So in some problems in section 4.2, they're going to give you exactly this kind of a setup. Maybe it's not population now, but it's going to be a point and then another point. They often will tell you how to define your variable. They'll do this kind of thing here because it simplifies our equation, right? Then part B would be, well, when will there be, what, Jeff? 3,600 people in the town, right? So this would be part A. Part A is find a linear function. Part B could be, when will there be 3,600 people in the town? So you guys try to solve that. So we got the equation. So now it's when will there be, don't say anything by the way, just keep it to yourself. When will there be 3,600 people? What does X represent? Years. What does Y represent? People. 11. You gotta keep those straight, because otherwise you just throw numbers in the wrong place. You get some funky answers, right? Like in the year 3000, no. All right, who thinks they have that figured out? Yeah. Yeah. So that's not the answer though, right? Now that's right, I'll tell you right now, that is correct.
Oh,
When is that?
why or no?
When is that? What does the X variable mean?
Oh, so
Alright, so let's catch up to you. So you put 3,600 in for people, and now I'm trying to solve for how long that is. minus 500, 3100 divided by 100. So you get x equals 31. 31 years since 1990 means the year 2021. So it already happened. So I like it. 2021. You guys see what I'm saying? Be very careful at the end of any damn word problem. Make sure the thing you got actually answers the question. Just go back to the question. In the year 31, that would be weird, right? The town is going back in time. All right, how you guys feeling about that? I mean, those are word problems, but they're what I call baby word problems. They're not. A real word problem would be like the one I made jokes about before. The train leaves Wyoming going south of this, but how long till the trains fly? This one is just slope, y-intercept. Translate what they give you into a point, and then you can how to handle that from there. It's my okay. All right. So chapter 4, we only do 4.1, 4.2. This should mostly be a review. And I got the feeling that most of you guys remembered like mx plus b and all that stuff. You might be a little rusty, but 4.2 is not that far away from just a basic find the equation of a line problem. Okay, maybe. All right, so what I want the bulk of today to be, we just finished chapter 4. I want to focus on chapter 5. Oh, next time, I'm definitely gonna, next Wednesday I'm gonna have to miss class. I'm gonna try to find a sub, I'll see if I can. If not, okay. I'm almost certain I'm gonna have to push the test back to the next week. We kind of talked about that because we had to push the first test back, so. I'll have all of that. I'll have an updated homework sheet next time for you guys, so you can see how the pacing's been affected. Are you with me? Okay, good. Just want to get that out there while I was thinking about it. So the really nice thing about section 5.1 is we already done a lot of it. We just haven't called it what it is. So what do I mean by that? So can anyone tell me, this is 5.1. So can anyone tell me the transformations that are happening here?
Right 3 of 4.
Yeah.
So right 3 of 4. Yes. And of course, the base function would be a parabola with the vertex where? What's the base function? Where does it go through? Where's the vertex?
3, 4.
No, not that one.
Oh.
0, 0. I'm getting a little ahead of me. So I guess I want to think that's the base function, correct? Before you move the damn thing, it's got its butt sitting at 0, 0. Yes? The technical term is butt, but we call it vertex. So, like you just said, where has the vertex moved to?
3, 4.
3, 4. Is that all right? So, what's really nifty, and by the way, please get off your phones. What's really nifty is if you put an equation in the right form, for example, a linear function, you can see the slope and the y-intercept. If you put a quadratic in the right form, you can see the vertex jump out at you. Can you also tell me which way this thing opens? Does it open up or down? Up. Kick ass. So what if I gave you, see how you guys feel this. If I gave you this, and I want to know where the vertex is. Some of you guys might know more than we currently know in the class. I don't care. We only know what I've told you so far. You don't know any shortcuts, any of that stuff. So is that in the right form for me to just tell what the vertex is? No. No, damn it. So does anyone know what we have to do to make it look like This. Sort of. What's the name of the process that helps me get stuff together like this to make it something squared? Completing the square, right? So watch this. If I put the +1, move that over a little bit, right? What are the steps for completing the square?
B over 2 squared,
Yeah, so the first step,
-6 over 2
-3.
squared.
Right, always in these, and if the first number's a 1, of course, right? Second step, square that thing. What do I put here?
9.
+9, right? Now, you ready? I don't really have two sides to this. This isn't really an equation, do you guys agree? This is a function definition. And it really makes me sad how few people get this nowadays, but Indiana Jones, have you ever seen that movie? The first one. They're really, really good. He took the gold statue and he put the bag of sand there and he didn't balance his equation correctly. Now I know some of you guys have taken chemistry, that means an entirely different thing, I'm sorry. If I'm gonna come in here and add frickin' 9, that's like adding the bag of sand, I better at the same time,
Add it to the other side.
nope. If I'm gonna put the bag of sand there, I better take the damn statue away, correct? I want to replace something with some. So if I'm adding 9, I better at the same time subtract 9. Did I just actually do anything?
No.
Nope. So mathematically, like algebraic, like arithmetically, I did nothing.
Well, that is 0.
Yes, exactly. Way to go, Jeff. Good job, man. But what can I do with this, of course, now? It's a little side note. And of course, as always, this tells me how to factor it, but that's pretty easy to factor. Okay, let me let you guys, all right. The one new twist to completing the square in this situation is I don't really have another side. I sort of do, but I really don't. So when I add 9, I better subtract 9, so I just did nothing. I didn't make it a different problem. It's the same problem. Yeah.
Don't you have to subtract 9 from the other side then?
Of course not. Of course not.
You just subtracted your own 9 there?
No. Was that there in the first place?
No.
Didn't I add 9?
Yeah.
So if I also subtract 9, I just did
You
nothing.
balance.
So I'll do the same exact thing to the other side. Done. Because I didn't do anything.
Is that plus minus supposed to be an equal?
That method is complicated because like
Sorry?
you have to figure out the exact.
Oh, this is an equal sign? Is that
No. The next to the 9.
Here?
Yeah.
No. Alright, let me see. Okay. Alright. You guys with me? That's the same.
Oh, okay.
Right? That's the same? This tells me I better add 9 so that this piece can factor. I better subtract 9 at the same time so I didn't make it a different problem. It's still the same
I
problem.
get it.
We're
Yeah.
gonna have a lot of clean the square problems in the test, the quiz, the test.
What do you think? What's your sense?
Hopefully not.
Alright, you can hope. Hope is good. Yes?
Why, when we did completing the square in the first one, we just add the 9 on both sides.
True,
right?
true.
What makes this,
Because I don't really have two sides. This is a
Oh, it's the
function
same.
definition.
Okay.
It's like all the stuff is on one side.
so if you had an equal sign right there, then you would have to do the same thing to both sides?
Exactly. I love it. Yeah, we're not used to this because normally we have two real sides of a normal equation. This is not an equation, it's a function. So I gotta work on that now. Technically, you could do blah, 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 but it's good to just be able to do this skill where you work on one side alone. You're just balancing it. So watch this. Now that it's in this form, can somebody tell me what the vertex is?
3 -8.
Yeah, because I would move right 3, so that's 3, and then I would go down 8. Okay, I like it. Cool. Yes.
I still don't understand why it moves, like, to the right, it's, like, negative.
So if I have this, how do I make that 0? What do I put in to make that 0?
0.
If I have this, what do I put in to make it 0? Didn't your inputs all become 3 bigger? To make 1, I would put 1. To make 1, I would have to put 4. Do you see that?
Okay.
All of my inputs become 3 more than they used to be. What does that mean graphically? It shifts to the right. And again, I think most of you guys have gotten used to this now, but it's really weird when your brain sees a minus sign, but you gotta tell your brain, no, we're actually gonna move right. And it's because somebody's taken $3 away from me, right? I wanna get in the club, it costs $10. If somebody's gonna take $3 away from me, how much money do I need in the first place? 3 more, 13, to overcome the -3 this jerk is doing to me at the door, right? He's always there. Damn it. All right. Guys with me? Okay. So this is kind of, I need you to see this, because this is going to happen a lot to us. If I put a line into y = mx + b form, I can read a lot of shit right off. I don't have to do where I can just look at it and sell the slope and the y-intercept. If I put a quadratic function into this form, I can just read off the vertex. I can also see if it opens up or down, right? Yeah, like it. So, we're going to take this whole thing. You know how this works. We're going to take it to the next level. Okay. So what if I have let's see. Let's make this plus 10. Can anyone identify which part of this sucks now, considering I need to complete the square? The 3, right? The completed square is easy when the first number is a 1, because that's what it's got to be. It's hardwired to do that. So here's where things get a little nifty. I'm going to move the plus 10 over. Don't even worry about it, just move them out the way, right? And then I can take a 3 out of there. Now let me say something really weird here. Like that's all you ever do, Jeff. Is there a 4x in my original equation? No, of course not. There's 3 times that, yes?
Yeah.
Keep that in mind. You all know that, you all see that. There's a 4x right there, but it's not a 4, it's a 12x, of course. Yes?
How can we just take the 3 out of the x?
Because I want to. No, I'm sorry. I'm not factoring this, I'm trying to put it in the right form. And what's the right form? The right form is some number times, so here's what the real form looks like. You guys agree with me? That's basically the form we got to over there. Why is this not, can anyone tell me if it's in this, can you tell me what the vertex is? You can. What's the vertex of this?
H and K.
Yeah, the vertex is HK. Okay, I like it. So, the reason, it's not even a question about why am I allowed to. I'm always allowed to do a lot of shit that's not helpful in general. I can, if I asked you to factor this thing, could you take a 3 out of just these 2? Yes. Would it be the right step? Hell no. Do you guys agree? If I just said factor this, that would be silly. Could you do it? Hell yeah. Does it help you? No. The question here is not factor this. It's put it in the right form. So, real quick. Don't say anything out loud. Everybody should know this. Just looking at the inside here. Don't say anything out loud. Think about it. What are the 2 steps I need to do? Figure out what number goes here. It should be nice and straightforward. Okay? So you take half of the middle, and then you square that, right? So I'm going to put a plus 4 right here. Okay. Remember what I said earlier. Did I actually just add 4?
No.
Nope.
Add 12.
I added 12. Do you guys see that? if I put a +4 there, I actually just added 12. So I better subtract 12. Let me stop for a minute. Okay, that's all right. Like to be tricky sometimes, but you guys look like you're doing okay. So then how does that factor?
X plus 2 squared.
Yeah, 3x plus 2 squared minus 2.
Vertex would be -2, or -2 and -2.
Oh, okay, okay. Vertex would be -2, -2. Yes?
Why is it 12 on the other side?
Why is it, sorry?
Why is it 12 on the other side?
Okay. Do you agree with me that this is something we just put there? Okay. Is there 4x in the original? There's 12, right? Because there's a 3 in here. Did I really just add 4?
Just add 12.
I added 12.
Oh, yeah.
If I multiply this through, isn't that a 12?
Okay.
So I better at the same time subtract 12, so I didn't change the problem. Yeah. Okay, I like it. I like it. And of course, this is another one that opens in which direction? Upward. Upward. The 3 means it's going to be skinnier. It's going to go up higher, faster. It's kind of related to the slope, like I talked about last time. So, what I want you to do, yeah, this isn't too evil of a problem. No, okay. I'll give you a little hint. All right. I want to know the y-intercept for the function h. Right. And then I want you to plot the vertex and the y-intercept. Just plot those points, and then I'll come in. Say again?
Inside parentheses, that it's two.
Say again? Sorry? Here?
No, down, that way,
Here.
yeah.
Two. Because that's how this factors, of course, right? That factors like x plus 2 squared. Okay. So just do that much. Don't connect any points. Just plot. Just figure out the y-intercept. And then plot that in the vertex. Oh, go ahead. Yeah.
Thank you.
How do you always find the y-intercept?
Set X for 0?
Set x equal to 0. I like it. Now, I could do it here. In fact, I'll do it here, and then I'll show you why that's silly. So if I make x 0 in here, I get, now this is a mistake people make, is that's not 0, right? So 3 times 2 squared, 3 times 4 is 12, minus 2 is 10. But of course, if I would have just looked at the beginning, right? If I make x 0, it's freaking 10. I can just see it. Do you guys see that? Yeah. So this form is easier to tell what the y-intercept is, and this form is easier to tell what the hell the vertex is. We are going to get a shortcut, thank God. We're not going to have to do this forever, but you are going to have to do this a little bit. Okay. So the y-intercept is 10. This is the silly way to do it. This is the better way to do it. Y-intercept is actually what, though? This is the word. What's the y-intercept? 0, 10, 11. So if I plot 2, 4, 6, 8, 10, and where'd it go? -2, -2, 2, 4. -2, -2, blah. Where would the mirror go that it would be reflecting around? Where would the symmetry line
Go
go?
over.
It always goes through the vertex for a parabola, right? Because that's the point around which it's symmetric.
Go over.
It'd be a -2.
-410.
We're getting there. All right. So there would be a mirror right here, correct? Always through the vertex, because that's the point. If I flip around, it's the same damn thing. So the vertex is kind of like on the mirror. And like Philip said, if there's a point here, where's the reflection through the mirror? This is 2 over from the mirror. So 2 more over will be the reflection point. I need you to understand that that kicks a lot of ass. I don't have to find a third point algebraic or arithmetically. I could just freaking do a reflection to get the third point. You guys kind of with me? So when I want to go graph these things, if I know the vertex and the y-intercept, I just need to get a reflection point. I don't have to do the work for it. How you guys doing? Does anyone know what the name of that dotted line is?
Symmetry.
See?
Line of symmetry.
Yeah. We call it even something freakier. We call it the axis of the axis of symmetry. Does anyone know the equation of that dotted line? What is true about every point on that dotted line? There's something they all have in common.
What about the 3?
What about the who?
What about the 3? The 3 right there. Yeah.
Oh, here?
No, in the equation, the 3. Doesn't it mean that we have to raise it by a factor of 3?
Did we apply transformations just now? No. You with me?
I don't know what that meant by to be applied.
I didn't plot the base function and then move it, correct? If I did that, I would have to triple all the outputs. Are you with me?
Yeah.
Okay. What we did was, we know the vertex, we know the y-intercept is definitely 0, 10, correct? And there's a reflection point. Now, if this would have been a 2, that would have been wider.
Stretch, right? Or what's it called?
Well, yeah. The bigger this number is, the more vertically stretched it is. Yeah, it's like somebody pulling up on it. Yeah. You guys kind of, are you guys at all with me? You guys, if I put a 1/2 here, now it's going to go up half as quickly. Right? If I put a 7 there, it's going to be stupid skinny going straight up.
So why is the vertex -2, -2? Isn't it +2?
So if somebody's going to give me $2, yeah. All right. So when it's in with the letter, you have to do the opposite of what it looks like, right? Does that make sense? Okay.
What about the other -2 though? Because on the last one, we had a -8 outside of parentheses, and the vertex was 3 and 8.
No,
So, you
no,
know,
definitely not.
maybe
No.
you wrote it wrong then, because I definitely wrote it.
Could be, maybe.
So if it was, if you were subtracting 2, would it be like +2?
Yeah, if that was a -2, this would be a 2, yes. Okay. All right. You guys all with me? So I apologize if I wrote that down wrong, but definitely this would just take it down 2. So that's why the vertex just goes down 2. Okay. So are we basing the shortcut stuff on transformations? Yes. Am I actually applying a transformation? No. Okay. This is kind of nifty. We get a point easily, and then we get a whole other point easily, right? Just the reflection across the mirror.
So 3 doesn't mean anything.
It does. Okay. You ready? All right. So we got that. Okay. Let's see. Yeah. All right. So, what if? Let me write this up here. It was 3x. What was it now? Plus 2 minus 2. Okay. Now watch this. Okay. Just to address that question. What if I did work to something and I ended up here? Right? You with me? What if instead of this, I had one that had a 2 in front, and when I did the work, I got to here? You with me? So your question is, what did that number do to my graph, correct? How do we investigate that? We change the number and we see what happens. Are you with me? Okay, good. Can somebody tell me what the y-intercept is for this guy? It's a little rougher, right? Because I didn't give you the full, but you can still do it. Make x 0. 2 squared is 4, times 2 is 8, minus 2 is 6. So the y-intercept would have been 6. The vertex is still where? Where's the vertex? Negative 2, negative, same as before, yes? So where would the reflection point be now? So here's one point. If I reflect around the mirror, it would be over here, correct? I need you to see that. I really want you guys to see that. If there's a point here and parabolas are symmetric, there must be a point the same distance on the other side. That's so cool. I don't have to plug shit into the equation. I can just do it visually. That kicks so much ass. Do you agree with me that that's not the same parabola now? Is it pushed down a little bit? Why? Because I put a smaller number out front, the slope is less, it's going to go up not as quickly. Okay, all right. Okay. Can't do more than answer your questions. Okay. So let me give you one to try completely on your own. And then we'll do one that opens down. See how that goes. I'll give you one that's not too evil. Let's see. Yeah. Yeah. So try to get it in the right form so I can see the vertex. Let me put all this up here. So put it into this form. Find the y-intercept. Then of course graph. Find the vertex. Just to remind you a little bit, you can already see the y-intercept, right? Yeah. Oh yeah. See Lisa, are you out there? Lisa. Dahlia. There. Lane. Hey.
This was, this is your current average, and this is what it could become if you make corrections to the law.
Aaron. Eunice. Raul. Same thing. Correct. What it could become if you do all the corrections right. No, that's great. Oh, the current average. All right, I put it on. Information overload. Thanks, man.
Oh, so subtracting the one that I added on this size and
Oh, remember you supposed to do the times one?
this one. Because 6 times 1 is 1. Oh, no, it's 2.
Still only 2 times one.
All right, guys, so what is the first step on this? We catch up to you a little bit. Sorry, move the 4 over a bit, but I have to. Yeah, take the 2 out.
Then divide 2 by 2.
Yeah, so the beautifully completed square is always the same steps. And no matter how ugly the number in the middle gets, you just apply the steps, just brute force apply the steps. It's not a ton of like guessing or whatever. So half of 2 is 1, squared is 1. What did I actually just add?
2.
So better
Minus 2.
minus 2. So then I get
X plus 1.
yep, good,
Squared. Minus 6.
good. So the vertex is
Negative 1, negative 6.
negative 1, negative 6. The y-intercept from the beginning was
Negative 4.
0, negative 4.
X the symmetry is on 1. Y equals 1. Or negative
Not y equals,
or X equals?
x equals. Yeah.
That's how you're supposed to put it, right? Like on the test, you'd want us to put X equals instead of just a number.
Exactly.
Or do you
Because
not?
a number is a number, the line of symmetry is a line.
So you want us to put X equals that.
Totally. So notice this, for parabolas that open up or down, the line of symmetry, the axis of symmetry, its formula is x equals x piece. Always. If it opens up or down. Later this semester, we'll talk about opening left and right. And of course, their axes will be this way. Right?
That'll be Y equals, right?
Exactly. Kick ass. So this sucker, if I start to graph this, let's see. Vertex is at negative 1, negative 6. The y-intercept is 0, negative 4. So the symmetry line is going to be x equals negative 1, right? And x equals means it's not moving left or right. If x must stay the same and I move left and right, that changes x. X equals means I'm only going up and down. So where is there another point?
Equidistant from the north.
Yeah, so just one step over, kabam. Weehaw. Weehaw.
Do you call it a vertical stretch by 2, or how would you say?
Yeah, the official name for this is a vertical stretch by 2. This process does not require me to apply this because like we saw earlier, it just comes out in the work, right? So I'm not purely moving and stretching a parabola. That's included in all the work I did. That actually is included in the y-intercept, yeah.
Let's say it was like a negative 2. Is it a vertical shrink?
No. We'll do a problem like that right now.
Okay.
Okay. All right, maybe. Everybody okay so far? The weirdest part about this normally is the everything on the same side thing. And then, of course, just remembering when you put a +1, you did not just add 1, you added whatever that is times 1, right? That's the weirdest part to keep track of. So if there was, here, let's do this one together. I gave you, we're doing it together, so let's make it a little bit more gross. Let's see. Sure. Let's see how this works out. So right off the bat, you can tell me two things about this problem. What can you tell me?
It's going downward.
It's going down.
And the y-intercept's 2.
Y-intercept is 0, 2. Kick ass. So it opens down. Y-intercept 0, 2. So everybody see that? You can see that already. So the only thing I don't know is the vertex. So I have to do what first?
Divide by
I'm going to move the +2 over. Take a -4 out, what happens?
x squared minus
Good.
4.
By the way, I don't even know if I want to say this, but I'm not really factoring again. So don't take an x out. That's going to make everything get really, really weird. You with me? I'm trying to leave my squared stuff, so the next thing I can do is that. So now, how do I figure out what goes here?
Divide by
Yeah, half of that is -2 squared is 4. So what did I actually just do?
16.
Yeah, I just subtracted 16. You see that? Does everybody see that? -4 times 4 is -16, so I better do what?
Add 6.
Add 16. It's pretty okay with the fact that I didn't subtract 4. When you put a +4 there, you did not just add 4 to this equation. You subtracted 16, correct?
How did you get 4?
Alright? 2 steps. What's the 2 steps for completing the square?
You divide the middle one.
Yeah, take the middle one divided by
Half.
2, -2,
Oh,
and then you
okay.
square. Yeah, so that's where the +4 came from.
Where did the -4 come from?
Oh, here?
Yeah.
Took a -4 out, right? So that becomes positive, that becomes negative. We took a -4 out, right?
Oh, that's 16. Okay.
Yeah.
I'm stupid.
Okay. I thought that was a pretty good 16. I write terribly, so I'm happy when I write something that's good. I'm sorry.
I'm just tired.
Does it look like a 1B? Alright. So, how does this thing factor then? So I've got my -4 sitting out there. This becomes, yeah, the great thing about this is it tells you what's going to go in here, and that's not hard to factor anyway. And then I got a plus.
Minus oh.
Yeah, tell me.
18?
18, okay. 2 plus 16. So where's my vertex?
Positive 2.
218. I like it. So now I've got all this information, and then you can graph it like we have before. Yeah.
So what do you call the -4?
What do you call this guy?
No. Yeah, like it's not a vertical stretch, is it?
It's still a stretch, it's also a reflection, so it's two things. The negative is a reflection,
Across
and the 4 is a stretch, right?
So-
So you could stretch it and then reflect it. So it's still a stretch. The negative is a reflection, does that make sense?
Oh, okay, so the negative in sorts just means it's reflected across the
Totally.
x-axis, so the
Yeah.
4 stays the same.
And then the 4 means the same thing, it always says stretch it, but now instead of stretching it up, you're stretching it down. Does that make sense?
Yeah.
And because when it's negative, it's a frowny face, and when it's positive, it's a happy face.
Sure. That'll work. Oh, okay. You got time. You gotta go, it's okay. Okay. Now, I do want to talk about, let's see, is this too early to talk about? Probably. I kinda hate leaving it there. I think they do this later. Kinda sucks. Oh, maybe not. Oh, cool. They don't. Okay, good. Alright. Last thing we'll do today is, please dear God, Jeff, is there a shortcut to this shit? Right? And there is. Okay. Help me out. Let's look at a quadratic in a slightly different way. Let's see. Sure. Okay. Yeah, if I want to know the x-intercepts for this, what would I do?
Well, you start by turning f of x into y.
And then replace y with 0. So to find the x-intercepts, I have to factor this. How does that factor? Yeah. So I know the x-intercepts then are what? 4, 0, and 3, 0. Okay, good. All right. So right with me? Now, what's a very true, I love it. What's the fact about parabolas is they're symmetric, correct? So if it goes through a point here, it must go through the other point there, right? So if I have 2 points across from each other, where's the vertex? In the middle, because it's always got to be symmetric to it, right?
Yeah.
So if I plot these points, where's the vertex going to be?
Lower, 3.5.
In the middle?
Yeah, in the middle. You guys with me? So it's going to be somewhere in the middle. You're with me, right? So what's the x value of the vertex going to be? Don't know. They're in my next class. It's okay. Where will the x value of the vertex be? Right in between 3 and 4. So what is it?
3.5.
3.5. You with me? Not the best value ever, right? You hope for whole numbers, correct? So do you want to complete the square for this? Do you understand what that would take? Half of 7 squared, do you want to do that? I don't want to do it even, right? Even though I'm cool with fractions, I don't want to do it if I don't have to. Let's develop a shortcut then. Didn't we just kind of see a shortcut? How did I find that? Did we already find kind of did we find that the vertex has to be somewhere on 3.5? So then how would I figure out the y piece? Plug the damn thing in, right? Okay. So if there was a nice way to always get this number, because that number is just in between. So very quickly, I want you guys to be really with me on this. If I have a incomplete graph of a parabola, let's say I've got, let's just think over here, 1 and 2, 3, 4, 5, 6, and 6. Sure. Why do you have to make it so hard? 1, 2, 3, 4, 5. Let's just do this. Okay, 1 and 5. I know those are my intercepts for my parabola. Where must the vertex be?
3.
Yeah, 3. I don't know where. I don't know if it's down or up, but I know the vertex lives somewhere on this line, right? What if instead of such a nice function here, what if I gave us what do you got? Why is this not as nice of a function if I want to find the x-intercepts? Yeah, this one's factorable and this one is not. So what would I have to use? Quadratic formula. Okay. Now go with me. Let me remind us what we just figured out. If I know the intercepts of my parabola, where's the vertex? In the middle. You with me? That only makes sense. If I know any 2 freaking points across from each other, the vertex is in the middle. Because it's symmetric, right? I know. One more time. What's the quadratic formula?
You have if b plus or minus the square root of b squared minus 4ac all over 2a.
All right, let me write this a little bit differently. You agree that it's the same thing?
Yes.
I just broke it up. need you to notice, won't this tell me the x-intercepts? This will give me the x-intercepts. Do you guys agree? Okay, good. Do you notice that this number, whatever that number is in the middle of the answers? One answer is take this number and add shit to it. And the other answer is take this number and subtract the same shit from it. Won't negative b over 2a be right in the middle? And what would you say if I know the intercepts isn't the vertex right in the middle? So the shortcut, let's apply the shortcut and then I'll let you guys out of here. I can sense the shortcut to find the x part of the vertex is just take negative b divided by 2a, because that will always be the number that's in the middle of the I don't need to find the intercepts. I could just do this. So what's b? Negative 7. And what's a? 1. So this will be 7 halves, and that's 3.5. Isn't that what we said earlier? Or was that 3.5? Are you with me? So that shortcut gets me the x piece of the vertex, and then to find the y piece, I just plug that in. Anytime I know an x, I plug it in to get the y. All right. So again, today was weird. I had to move the room. I spewed a lot of shit at you. Next time, I don't know if you guys have noticed this method in my madness. I'll have a worksheet that you guys will work together on, going over what we did today, and then we'll do some new stuff. It's crazy. We're gonna meet in this room from now on. But I'll still put notes on the other room because some people won't be here today, so. All right, guys, let me know if you need me, otherwise I'll see you next time. If you have any homework, give it to me.